Thank you, everyone. Thank you. It's great to be here. This is a fun, like you're all standing. It's like a concert. And you're pre-tired, so I'm going to try to be fast. And I have a lot to say, so I'm going to be jumping a bit fast. So we're going to talk about modern Python through FastAPI and friends. First, who am I? I'm Sebastián Ramírez. I live in Berlin, Germany, but I am from Colombia, South America. That's why the accent. I made FastAPI and a bunch of other tools, or open source tools. So FastAPI, how many of you have heard of FastAPI before? Oh, actually, like a lot of you. That's very cool. Nice. That's very fun. So for those of you that don't know, FastAPI is a web API framework, and it has been growing a bit and used by a bunch of companies, and like it has relatively acceptable performance, and like, you know, a bunch of people have liked it. So that's why they brought me, because FastAPI. So, whoops. Yeah. So we're going to talk about modern Python, and by modern Python, I actually mean the currently supported versions of Python. So 3.7 that is about to be deprecated already. This is the things that I'm telling you about. But many of us have been working with Python for a while, and not necessarily are using like all the new features that we have in the language. So that's what I'm going to talk about today. We're going to talk about, a bit about FastAPI, typer, SQL model, and some of the friends and libraries internally. So f-strings, a lot about type annotations, then a bit about async and await, performance, community. So let's jump into it. So first, f-strings. I hope many of you are using them already. If not, yeah, let's see how that works. So let's say that we have some data. It doesn't matter that much what data we have. And then we have some function that is handling that data. Now, if you see, we are here, we are generating some data for our recipe, and then we are duplicating this information that we are using this name, and we are formatting this string with the keyword name is going to have the value name. So we are duplicating the information 3 times. If we run that code, then we call the function, then we get the result. If we pass the quantity, then we get the result with the total here. So that's all fine. That's how it works. Now, this is how we use f-strings. We just put the f at the beginning of the quotes, and now we can include whatever are the variables that we have in the scope. So this name comes from the parameters here, and we can just use it internally. That's it, very simple. And if we call it, it just keeps working as we expected. Nice. Now they can get rid of very complex stuff and have simpler stuff. That's it about f-strings. I hope you're using f-strings. If not, please just start using them. Now let's jump to type annotations. So let's say we have the same function, and then we try to trigger autocompletion in the editor. The editor doesn't know what is the type of this variable or this parameter name. So it will just like say random stuff because it doesn't have a way to know what it is. And then like, you know, like we have been working with type annotations, so like that's how things have been forever. Like we are not gonna change stuff now. But actually we could just add the type annotation here. This is all we have to do. We don't have to add types to all the variables internally in the code, just to the parameters in the function. And then if we add these type annotations, now suddenly the editor knows what is the type of this variable, so the editor can provide autocompletion. So like, you know, when we talk about type annotations, academical people tend to say like, oh, static analysis and type safety and all that stuff, but like that sounds very sophisticated, and like the main thing, at least for me, is like autocompletion. I want autocompletion in the editor. I suck at programming. I don't have good memory. I need autocompletion. So this is what we get, autocompletion. And because the editor knows that the result of calling name.replace is also a string, it can keep providing autocompletion there. So we only have to add the type annotation there in a single place in the parameters of the function. And that's it. And now we can have autocompletion and type checks in all the code. That's great. And now, okay, this is how we take the code. Now we can use the title, and we can use it internally. We don't have to remember what are the names of this method. Like, is it title? Is it uppercase? Is it, what was the thing? How is it that you call it? You just trigger autocompletion, and then the editor can help you get those things. And if we call it, it just keeps working as before. Like, it doesn't change anything internally. It's just like for the autocompletion and for the inline errors and that stuff. Now let's say that we want to refactor that function. Not necessarily everyone wants to get a whole recipe, like the whole thing. They don't necessarily want to have an amount of these food items. They maybe just want to get the recipe, just the single recipe. So we are gonna change quantity. Is now not gonna default to 1, it's gonna default to none. Sounds like a very simple refactor, and that's cool. And then we just have this code like this, and then we run it, and then when we run it is that we see that we have an error in the code. And then we have this large things saying like, oh, traceback mostly, blah, 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 blah. You know, like those very large tracebacks with a bunch of code and a bunch of like the internal libraries and a bunch of things. And you have to squint to see where is the problem, where is the error in your actual code. And this only happens whenever you are running the code, which might be in a production application. And then you're just like checking the logs there. So it's like a complex process to get to the point where you see, oh, I'm actually making a mistake here because I'm trying to multiply default price for quantity, and like quantity can be none. So it's a difficult process to get to the point where you see the error and to see what is the problem, or what is the thing that you did wrong. But if you add the type annotation, so quantity is gonna be an integer, but by default is none. So if you say this is an integer, but by default is none, the editor is smart enough to know this is an integer, but it could actually be none. And then, let me go back for a second. Now we can see that we have this red squiggly line here. And if we hover with the pointer in the editor is gonna tell us what is the problem. Hey, you cannot multiply an integer with none. This is not valid, like you are doing something wrong. So the editor is telling us exactly what is the problem right there while editing the code before even running it. So we have the type hints are actually protecting us from a bunch of bugs. And like we never make those bugs because we didn't commit the code. We fix them before we commit, and then like we don't have to wait for that to explode when we put the application in production, because like we already fixed all those bugs before anyone noticed that we committed those bugs. And we can then say like I'm a 10x engineer or something like that. Now let's check this. So now the default price cannot be multiplied by none. So we can just fix it. We are gonna check if quantity is not none, and then if quantity is not none, now we can actually multiply it because we know that quantity has to have a value. And the editor is smart enough to know that inside of this if block, quantity has to be an integer because we already discarded the option of it not being none. So this is actually gonna work. Like, then this is how we use it internally, but we can see that we still have a red squiggly line. So what's happening there? If we hover over, it's gonna tell us, hey, you're trying to add a new type of data to this dictionary that we had before. So I was expecting to have a dictionary that only had strings or that has sequences of strings, and you are adding an integer here, so what is happening? This is just that the editor is being super smart about inferring what is the data type of this result over here. So it's saying like, oh, I see that this is a dictionary that only has keys are strings and the values are also strings. So this is the only thing that I'm gonna accept. But we can also tell the editor, hey, just don't try to be so smart, don't try to be so strict. This is just gonna be a dictionary or whatever. Like you just don't care about that. I know what I'm doing. Famous last words. But let's say that I say like, I know what I'm doing. This is just a dictionary. Let me do my thing. And then the editor now knows, okay, this is a dictionary, hands off. I'm not gonna try to infer what type of dictionary this is. And now we get rid of the red squiggly line. So we use the type annotations to get those red squiggly lines. And we also use the type annotations to get rid of those red squiggly lines in the places where the editor is trying to be too smart and to try to help just too much. And now, because the editor is smart enough to know that quantity could actually be none, then the editor knows what are the possible types of this quantity inside of the code. And if we check inside of the block of the if statement that is checking, hey, if quantity is not none, the only possible value for quantity is an integer, and the editor knows that. So we're gonna have autocompletion and inline errors internally, knowing what is the actual type of the value if it changes internally, or like if some if block discards some of the types. And now, if we want to be a little bit more strict or a little bit more explicit about things, we can, if you are in Python 3.6 or above, or 3.7, then you can, from typing, you can import optional to say, hey, this is optional int. Optional actually means this can be none. Optional really means the union of int and none. If you're in Python 3.9, you can just say int vertical bar none, which is the best syntax. That's the best way possible. But if you're stuck in a previous version of Python, then you can just do this. And this is like the most rigorous version of saying like, hey, this could be an integer, but it could also be none. And now we can be like happy, like this dog, just because we have type hints and we don't have to cry looking at errors in the log of the server somewhere else because some traceback and like all the stuff. Some of the people behind these type annotations. So these things are actually done by people, by very normal people like you and me. Well, sort of, but like they are very smart. But this guy is the one that created like the first version of the language, and like some of the main contributors to these things and to this language and to the things that ended up in Python. I just wanted to show you that, you know, like it's just like people behind these things. Now we're gonna switch a little bit, and we're gonna use FastAPI with these same type annotations. So we're gonna use the same code that we had before, same type annotations. Now we're gonna import from FastAPI, we import the FastAPI class, we create a FastAPI object, and then we're gonna decorate this function with app.get. And so we are telling FastAPI, hey, whenever someone sends a request that is an HTTP GET request, or an HTTP GET method, and goes to this URL, /recipes/, and you can see that this name is in these curly braces, so this means that this is a path parameter. It's the same syntax that you will use for an F string, but we don't have the F, so this is not really using a variable from above. But this is the way that we tell FastAPI, hey, I need you to extract this parameter from the URL. And then FastAPI is going to extract it from the URL, and it's going to put it in this parameter name, the parameter that has the same name of the variable here, and then it's going to get this value here. Now, this means that the more FastAPI code you write, the less API code you write, because FastAPI gets out of the way, and you can just write type annotations with Python, standard Python, and then just like put the little things on top with FastAPI, and then you have an API. That's the idea. Of course, you still get auto-completion, and like you can be happy, like this cat, having auto-completion everywhere inside of your code and your code base. And FastAPI is going to ask you to add those type annotations so that you can get like all these things. And you still get like error detection. And if you go with that same code that I just showed you, if you go to /docs, then you get automatically this API documentation user interface that is generated for you, because FastAPI is based on standards, so it can generate that from the same code that you have. So you have data documentation automatically from the same type annotations. And you can actually interact with the API that you are working with live and send data, and then get the result right there in the browser. So it makes it very easy to iterate and develop quickly with the same API that you are building. So you write some basic code, and then good guy FastAPI makes that docs UI for you. That's like the nice thing. Now, what happens if you send invalid data? Let's say that we say that quantity. In the code that I showed you, we had an optional parameter quantity that was an integer, but it could be none. It had a default value of none, which means that it's not required. Like, that's what it will mean if we were calling the function. That's the same thing it means when you are using it with FastAPI. It's just not required. Name is required because it's in the path, but quantity is not required. But quantity has to be an integer. If we try to send 9, then this user interface won't let us send 9 because it's checking, hey, is this an integer? But like, you know, the user interface is just in the front end. What happens if we try to, bless you. What happens if we try to go work around this thing and try to send something that is actually 9? So, we go in the to-hacker interface, the terminal. And then we send it like the URL with this question mark, the query parameter, this is going to be 9. Then FastAPI is going to check the data, and it's going to give us a result like this one that is validating the data automatically with the data shapes that we defined, with the type annotations that we defined. So it's telling us, hey, you have a problem in the query, in the parameter named quantity. The value is not a valid integer, and I was expecting to get an integer. So FastAPI is doing data validation for us automatically. That means that we don't have to do all that code that is validating the data that we received inside of the same function, because it's just like done automatically. So if we have invalid data, FastAPI is protecting our code from running with broken data. But if the data is correct, then everything just works smoothly as the type annotations and the auto-completion, like the inline errors told us. So we just have to make sure that we define the data that we expect to receive, and then FastAPI takes care of making sure that that's what we receive. We also get automatic data conversion. So if you see in the query parameters, we are here after the question mark, quantity equals to, this is part of the URL. A URL is just a string. A URL doesn't have a notion of, this is a data type of an integer or a float, or this is just a long string. But then, because FastAPI knows that this should be of type integer, FastAPI is going to convert that to the type that we define. So we are actually going to receive an integer internally. So it's doing not just data validation, but also data conversion automatically. And we can see that because like the total here is not, this is not a string, this is an actual integer. And this is all based on standard type hints. So it's the same thing that provides us autocompletion, and inline errors is giving us data validation, documentation, and serialization. And FastAPI is based on standards like OpenAPI, JSON schema, auto. You don't need to learn or know these things. The thing is that this is what powers the automatic API docs. It also powers automatic client generation and a bunch of things like that. And because it's based on type annotations, we get autocompletion and inline errors, but it also does automatic data conversion and data validation. Now, let's switch subjects. We're gonna do type annotations with typer. So let's say that you want to build a command line application interface, something that you interact in the two-hacker interface in the terminal. So what we are gonna do is that we are gonna import typer, and then we create a typer app, and then we decorate the same function with app.command. And then we can print the results here. You can actually just use print here. You don't have to use typer.echo. But then, like, because we are not returning something to a request, we are just like printing something out in the command line, so we add this extra line here. And now this is just like some typer salt, and now we have a command line interface application. We can call the function, the program directly, and we are gonna have a nice error telling us, hey, you are missing the argument name that was required. And then if we pass the name, we're gonna see the thing that we expected is gonna be printed out very nicely. If we pass a CLI option, like quantity, so you can see that it's also mapping the same optional parameter that we had in the function. Now we have an optional CLI option here to say what is the quantity that we expect to receive. Then it's gonna process that and it's gonna convert the data and do all this stuff. And we also get the same data validation. So if we pass as quantity, we pass 9. This is not an integer. I mean, in text is not an integer. Then we get an error telling us, hey, there's an invalid value for quantity. 9 is not a valid integer. 9 in text, you have to pass it as a number. And we also get, with typer, we also get a shell completion. So when you create a package using typer that someone else can install, like for example, there's a package called typer CLI that is built with typer, then the users of that package that you create with typer are gonna get automatic shell completion that works in you know, like Bash, C shell, Fish, even PowerShell on Windows, which is really difficult to implement, but it's gonna work. And then, like, whenever they hit tab, they're gonna get completion for the arguments, the parameters, like all that stuff. And now you can say, like, oh, I'm such a hacker building CLIs and stuff. Now let's combine typer with rich. Rich is this library to print and display information in the CLI in a very nice way. So we're gonna import a couple of things from rich. I'm not gonna show you like each line of the code, but the thing is that we are creating a console to print stuff, then we are creating a table, and then we are adding things to the table, and then we just print all that thing. So, you know, it's just like a few extra lines of code, but now suddenly we have a very nice user interface, well, like terminal interface for people to work with our code. So you can use typer and rich to build very cool CLI apps, and it's like very simple, all just based like, you know, on type annotations and these simple things. Some of the people behind these things. So David Lord is the maintainer of Click. Typer is built on top of Click. Click is the thing that does all the work underneath, and Will is the creator of Rich. So, you know, just people. It's just people behind these things. Now let's switch back again to building web applications, web APIs. We're gonna use FastAPI and Pydantic. So FastAPI is built on top of Pydantic and another library that handles all the web. The other library is called Starlet. It handles all the web parts. Pydantic handles all the data parts, data validation, serialization, documentation. All the stuff is handled by Pydantic. So let's say that we want to receive some post request with some data. So from Pydantic, we import the base model, and then we create a class. This is gonna be a food item to continue with Anja's example. So we're gonna receive a food item that is gonna have a name that is a string. Because this doesn't have a default, this is required. And it also has some ingredients, which is a list of strings. This has a default, which is an empty string, an empty list. So this one, because it has a default, is not required. Then we just define it here in the function. And this is the standard way that you use type annotations. This is the way that you say, hey, this parameter food is gonna be an instance of this class food. So this is not like, it doesn't mean that food is gonna be the class itself. It's gonna be an instance of that class. And this is standard Python types. And then FastAPI is gonna make sure that this is what we receive, an instance of food. And then we can use that internally, access the attributes, all that stuff. And if we check the automatic API docs, we can see that now we have this post request that goes to /food/, and then it takes some data that is defined with the same data types and the same attributes that we defined. So it's going to receive a name that is a string and ingredients, which is, well, in the example that is showing, it's just like an empty list, but it's going to be a list of strings. And then we can just use it interactively again from the same web UI, and then we can get like the results back from the same browser while we are developing. So we don't have to use another tool to communicate with the API. We have something that already has like all the communication set up for us to develop and to play and interact with the thing that we are developing. Now, what happens if we try to send invalid data? Let's say that we want to say something. This has a name that is a string. This is fine. Ingredients is a list. This is fine. The first ingredient is a string. This is fine. But the second one, this is an object. This is not a string. So this is actually not valid with the types that we defined. If we send this, then FastAPI is going to check all that data and validate all that data for us and tell us, hey, inside, it's not just going to tell us, hey, the data is invalid. It's going to tell us exactly where the data is invalid. It's going to tell us, hey, in the body, inside of the ingredients at index 1, a string type was expected. So it's telling us exactly where the problem in the data is. And you know, like it's just like it can work even for deeply nested data structures. So we just have to define things with the type annotations as we want. Now if we want to have even more nested data, we just use the same type annotations. Now let's say that we want to have orders, not just one single food item, but a list of orders. Then we just use again type annotations. This is going to be a list of instances of the class food, and then we can just iterate for each one of those. So if we want to have JSON and we want to have it inside of JSON, we just use the same type annotations and the same standard Python types to define whatever complex, deeply nested data structures or whatever we want, and we get validation all the way down for all that. And because this is all based on the standard Python type annotations, the editors can still give us autocompletion everywhere. Check that this is a double nested for loop, and we still get autocompletion for the methods of this. So the editor knows that each one of these ingredients that is part of this list of ingredients, that is part of each one of the food items, the editor knows that this is a string, so it can give us autocompletion for strings. So you get autocompletion everywhere in the code, and you can be happy like this guy. That's me coding. You also get inline errors for the same thing. So again, this is a double nested for loop, and the editor knows that you cannot sum a string ingredient with 9,000. Some of the people behind these things. So Samuel Coblin is the creator of Pydantic. Tom Christie is the creator of Starlet and a bunch of other things. Starlet is the thing that does all the web parts. David Montague is a notorious contributor to both and to all of these tools. Now, let's switch again, and let's use FastAPI, but now with SQL model. So SQL model is a library for interacting with SQL databases. So what we are going to do is that we are going to import. The thing with SQL model is that each one of these classes that you create, each one of these models is at the same time a Pydantic model and a SQL Alchemy model. So you can interact with the database and like avoid all the duplication of information and the duplication of these attributes in like a bunch of different classes to represent different things, because the same model can represent all of them at the same time. So now we are creating a hero. It has an ID, is the primary key. It has a name that is a string, secret name, age is an optional. For example, this age optional means that whenever we are receiving a request with that, it can be skipped because it has a default value, or it can be none. And it also means that in the database, this is going to be a nullable that by default is none. Then we just create an engine to create it. I'm not going to tell you like all the details, but like the thing is that we can then use this internally directly inside of the same FastAPI code, the same way that we will use Pydantic models. So we can use a response model, we can use it as the input, and when we can save the same thing directly to the database, and then we can return the same thing directly, and then like everything just like works. If we want to return multiple things, then we can define, hey, this is going to return a list of hero instances, and then we can just return the same heroes that we get from the database, the same instances of these things that come from the database. We can return it directly, and it just works with FastAPI directly. And because each one of these classes is at the same time a SQL model and a Pydantic model, we also get this automatic documentation, even for the responses, that is telling us that, hey, this is the type of data that you will receive. So we can have like database and data models without duplication. Otherwise, in particular, if you have a table that has like, I don't know, 12 columns, then you will have to define one class that has 12 attributes, and then another class with Pydantic that has the same 12 things, but defined in a slightly different way because you are defining with standard type annotations, and for the database, you are using whatever is the internal language of the framework that you are using or the library for handling the database to say, hey, this is a string. But then like you have to import from, I don't know, SQL Alchemy, import the string, and Pydantic just use the standard type annotation for string. In this case, you can just like use the same model with the same type annotations for everything. Some of the people behind these things, again, Samuel Colvin from Pydantic, Mike Bayer, the creator of SQL Alchemy. SQL Alchemy is the thing that does all the actual work underneath, communicating with the SQL databases. So SQL model is actually just a thin library on top, mixing Pydantic and SQL Alchemy. Now, let's switch topics. We're going to talk a little bit about Python with async and await. So, and this is just jumping completely from type annotations. This is like one of these additional new features of the language, well, sort of new features of the language. So what's the deal? The Python code is actually very fast if you compare it to the network. Before you start throwing tomatoes, is if you compare it to the network. So here's the thing, you have a client, the client starts sending a request, and then it goes very slowly through the network, and then Python can process whatever that request is fairly fast if you compare it to the network, and then it sends the response back, and it goes very slowly again back to the client. So what's the first idea? Let's have multiple clients that communicate with the same Python backend. So that way we can like take advantage of Python being able to be very fast, even though the network is actually slow. But it actually works like this. It doesn't really work like having multiple clients at the same time. It works like a queue going to pay in the cashier. Like, you know, like before you can buy your, I don't know, before this guy can buy the newspaper, has to wait for these toilet papers to go in. So that person has to pass the toilet papers and then pay them, or this guy with the, I don't know what's that, like, it's like a big wine, but I don't know. It has to pass all that, pay for that, before the guy with the newspaper can actually start his own transaction. So it's like one after the other, and each one has to wait for the previous one to finish whatever they are doing. So it's more like this. You have one client sending a slow request. This is like what it will work by default. There are like caveats and details, but like, you know, like you get the idea. This is just to give you the idea. So the client sends a slow request. Python can process it very quickly, and then sends the slow response back through the network. And meanwhile, all these clients are just waiting there, not communicating with the server, while everyone is just waiting for this slow communication through the network, just for cables, for electricity going through cables from the Netherlands to, I don't know, the United States or something. And the API app is just like waiting for the network, not doing anything. You know, like the CPU is just like there waiting, not doing something, because like it's just like waiting for the communication to go. So here's the idea. What if instead of each client going directly to the server and waiting for each one, if we had something like a waiter that is going to each one of the tables, taking their orders, and then like going to the kitchen and then asking for each one of those orders and then giving them back to all the clients, so everyone can be waiting at the same time instead of like waiting by turns. This is what we get with async and await, pretty much. It's like if we had a waiter inside of Python. So now, this client will send something, and then the waiter that is inside of Python, using this async and await stuff, can take that order, and then while that order is being cooked, this waiter can go and ask the next client. And then like, we are just waiting for this network sort of at the same time. During the same period of time, we are just waiting for this network to happen, but the waiter is actually sending orders all the time to the backend, to the actual code that is executing. So this thing can be super efficient, super fast, just using the CPU all the time, while this part is taking care of handling all the multiple clients. So, you know, like this could be my sister, and she takes a very long time to check the menu, and while she's just checking the menu, this other client could be asking whatever is the order that they want, and then the kitchen can start cooking all the previous orders, and like even the orders afterwards, while we are still waiting for this one, instead of like having everyone waiting for this one to finish. So that's the idea. Now, how does it look in code? So the thing is that you just add async to the functions, And then when you add async to the functions, you can use await inside of those functions. And then the things that you use await are functions that are also compatible with async and await. So the thing is, like, async and await is not something that you should just like use in all your code and migrate everything to use async and await. It's something that you have to make sure that it's like working and that is compatible with the rest of it. But this is how it works, and I'm gonna show you like how you can avoid those problems in a second. So for this await to work, this client.get has to be defined also with async. So you cannot just like put await in front of anything. You have to put await in front of things that can be awaited. And then you can also use these blocks like async with blah, blah, blah. Here we are just like talking to some external API. So HTTPX is kind of like the next generation requests or something like that you might have used just to communicate with HTTP, but it's compatible with async and await. And if you check the documentation and the automatic documentation, it just like works the same. This is just pretty much the same, and you get like the responses that just works all the same. But with FastAPI and HTTPX, using async and await is actually optional. So FastAPI underneath is an async framework, and it's gonna do like all the async stuff. But if you define the function without async, which is what you will normally do in most of the cases to be able to keep using the rest of your code that you already have, that is probably just like blocking a normal def functions instead of async functions, then if you define your function without async, FastAPI is gonna do the smart thing so everything works underneath correctly. If you like the technical details, this is just gonna run it in a thread worker in a thread pool. And then HTTPX is also compatible with async and await. So you can keep using the same libraries, in this particular case, with blocking code, and then you can migrate only the path operations or only the endpoints that really need to squeeze that extra performance to be able to handle better concurrency. So you don't have to, in FastAPI, you don't have to use async for everything, and you can use normal def and use async def only whenever that actually makes sense. And you can still use HTTPX, and there are some other libraries that also support this pattern. Some of the people behind these things, Tom Christie, again, is the creator of HTTPX and Starlet and a bunch of other things. Marcelo is currently the maintainer of Starlet and Unicorn, and the creator of the specification that allows all these things. A little bit about performance. This is a benchmark run by a third party, comparing a bunch of different languages and a bunch of different frameworks and stuff. Here is only showing Go, Lang, and Python. Go are the green lines, Python are the blue ones. Go is a compiled language, so Go has to be faster than Python because Go is compiled. Nevertheless, FastAPI and a bunch of others get to be like on the ballpark of like the best that you can get with Python. In some cases, even a bit faster than some of the frameworks in Go. So that's quite decent performance. Which one of these is faster is not necessarily that explicit because Unicorn is the server. This is not a framework, and everything here uses Unicorn, so Unicorn should be at the top. So, you know, like there's just some random error. But the thing is, in this particular benchmark, this was handling like 15,000 requests per second or something like that, which is over 9,000, so it's quite fine, quite acceptable. Now, why does it have good performance? FastAPI doesn't really do anything particularly smart itself, but it's built in on top of very good tools. So Starlet uses Unicorn, which implements the ASCII spec. This is just the specification for doing web stuff using async and await. And it uses UVLoop, which is a high-performance async drop-in replacement that is compiled with Python and uses libuv, which is the same library that is used by Node.js. You don't have to know all that. It's just that this is why it has good performance. And Pydantic is built with Python, but now it's been rewritten in Rust. And like the first versions, like the first alpha is already there. The first beta is going to be in the next days. So like now Pydantic already has very good performance. Now it's going to have like 10 or 20x more performance. And like because, yeah, they are rewriting it in Rust. So the thing is that FastAPI is built with very high performance projects, and like that's why it's fast. It's just because it's standing in the shoulders of giants. Some of the people behind these things, Tom Christie again, the creator of Starlet, Unicorn, HTTPX, Django REST framework, a bunch of other things. Yuri Selivanov, the creator of ULoop, he's also the one that added async and await to Python itself, and the maintainer of Python. You know, so again, it's just like a bunch of people behind these things, normal people just like trying to help others. Now a little bit about the community, and I promise it's going to be short. This is all done by normal people, and it's mostly during free time. For most of the people, all this open source stuff is during the free time. You know, at nights and weekends, you know, just like juggling crying babies and stuff like that, and they just like doing these things for us, just trying to help others. Like in my case, I'm actually been able to work full-time on open source because Sequoia, the VC firm, is doing this open source fellowship. So this year I get to just work full-time on open source. But for most of the people, it's just like, you know, their free time. And like, you know, maintainers tend to not have hobbies because they tend to be just like working on open source. So yeah, just trying to be kind to your maintainers. But there's things that you can help. And like, it's funny that, you know, like for most of the projects, even if they look very big, it's just like 1 or 2 people doing most of the work. And there's a lot of people using those tools, but there's actually very little people actually doing the internal work. Some of the things that you can help, for example, with FastAPI, you can translate a page to the native language, or you can review a translation from others, or you can answer questions from others. It sounds like simple, but it's actually the thing that takes most of the time. It's the thing that I get most of the help with because it takes so much time answering questions from others, just that. You can also help with books and features, or you can help with other projects, with like the internals of the projects, or whatever is the project that you are working on, the open source library that you are using. Whenever you are reading the documentation, you will probably find a typo. Make a pull request to fix that typo. That's the first step. And it's also, like, you know, whenever someone creates a library, they never read the documentation again to find those typos. So you are the one that is going to find those typos. So go and fix them, please. Help us. And well, nobody expects the end of the talk, but that's what I have for you. Thank you very much.